Hey, welcome to day 3 of making a maker. Today I bought a caliper, so I'm going to be using this to measure my candy, and that will help me determine whether the sieve method is going to be possible at all, whether the widening gap method is going to be possible at all, or whether I should just not bother with those. So just to give sketches of what each of these are. Let's see. Yeah, here. All right, so the sieve method, the active one, or sorry, the passive sieve was going to be a board shaped like this that was on like a slope, supported by some legs, and there were going to be some holes in it of various sizes, and so they would be in sort of like a cheese grater alternating pattern, like so. And the ones at the top would be the size of the smallest candy, so like Reese's Pieces or M&M, and then uh, and then the next smallest candy, which is probably the other Reese's or M&M. And so the idea is that the M&Ms would fall through here, and then the Reese's Pieces would fall through here, and then the Skittles would come at the bottom down here. And so the the hope was that I could just dump a whole bunch of candy right down there, and it would go down the sieve, and everything would be automatically sorted. So that was hopefully a very promising option. The active one was a slightly different design. So it was going to be more like a tube, like so, and it was going to be rotating, and so it would go clockwise or counterclockwise. And if you looked at the tube, well, all right, so first of all, it would have the same sort of holes that the passive method has, going along the length of the tube. And if you looked at the tube in cross section, it would have these baffles in it, like so. And what it would mean is that half of the tube would be blocked. And so this would be at an angle, and it would have an axle or some other means of rotating, perhaps on like bearings or whatever. And as the candy fell through, it would hit the baffles, and then it would rotate. And as it rotated, it would hit all of the various holes on the sieve. So the advantage that has over this is that there are only a couple holes that the candy will pass over, and so only a couple opportunities to correctly sort the candy. Whereas this, it would sort of be forcing the candy to interact with more of the holes in the sieve along the way, therefore doing a more effective job at sorting them. And so you'd get the M&Ms falling out here, you get the Reese's Pieces falling out here, and then the Skittles would come out the bottom of the tube. So the critical factor in either of these designs is that the diameter of the M&Ms and Skittles and Reese's Pieces vary enough that I can consistently make holes that are the appropriate width. So I need to measure those. Now the widening gap is sort of a similar idea, but done in the narrow direction of the Skittles or M&Ms. So if you look at Skittles, M&Ms, whatever, they're sort of an oblate spheroid where they've sort of been squashed down. And Skittles are much more sort of bulbous than the Reese's Piece or M&M. And so my idea was to, sort of like the panes of glass that you saw 2 days ago. Where was that, yesterday? I don't know. The days are kind of blurring together at this point. But you have two pieces that are, some sort of distance apart, and they're held together with a screw of some kind. The screw turns, and the gap gets wider, and the wider candy falls through. So as we saw with the panes, there's some stratification between the Skittles and the M&Ms and Reese's Pieces. But if I wanted to sort all three, my findings with the friction yesterday would make that more feasible. So what I'm going to do today is I'm going to measure several of each, and hopefully we'll get some consistent data for the diameter and for the thickness of each of these. So I'm going to do 3 of each. I will probably stop boring you with all of the details because really nobody is watching all of my videos all the way through. But I'll cut to the end of this after they've all been measured and save you the boredom. Okay, so I just used my brand new caliper to measure the diameter, also width in this case, and the height of the Skittles, the M&Ms, and the Reese's Pieces. The findings are kind of disappointing because while Skittles are indeed smaller than M&Ms or Reese's Pieces, both well in terms of width, and they are larger than M&Ms and Reese's Pieces in terms of height. The problems are this. One is M&Ms and Reese's Pieces are so close that there is overlap. So like the smallest M&M is 12.95, the largest Reese's Piece is 13, and the tallest Reese's Pieces, or sorry, the shortest Reese's Pieces is 6.43, while the tallest is 6.59. They overlap, and so that means that using purely physical dimensions of the candy, we cannot tell them apart. There's no way that you could give me the measurements of a piece of candy and I could, based on those measurements, determine whether it was an M&M or a Reese's Piece. Like, it's just not possible. So that really puts the kibosh on the sieves and the widening gaps. So I'm going to X those out. The slope with divots is the same idea. I was counting on the curvature of the piece, and while Skittles do have more curvature, there's no significant difference between M&Ms and Reese's Pieces. So I can eliminate the slope with divots and the sieve, both passive and active. So that really leaves the friction. I called it rolling, but I'm going to change that to friction as the most promising option here. Over rotation, that's where I was seeing the stratification between the two glass panes. If I really want to go for nailing all three, then friction is the only one of any of these that actually delivers. So that pretty much settles that. So I've been doing some thoughts about designs of various machines that could make use of the friction in order to distinguish the candy. And I've got 2 designs rattling around in my head that appeal to me. So first is the moving flap. So let me draw out the moving flap design. So the way that this would function is that there'd be something that loads the candy, and it will load it 1 or 2 at a time, and I still have to figure out the mechanism by which this will happen. But 1 or 2, not many candy at a time goes onto a flap. And the flap is like this, and is made of the cardboard. So by whatever mechanism, I have the flap rotating, and it goes between horizontal. So this is going to be like this. It's going to come straight down to the flap, and so the candy is going to sit right there. There might be a little bit of a gap here. So, the candy will essentially be freestanding on the flap when it is horizontal. The flap then slowly tilts downward so that the static friction of the candy is the main force keeping it in place. And as it lowers, so it'll hit these different angles. And so I'm just going to and one last one. So this is fairly similar to what I saw with the M&M's, Reese's Pieces, and Skittles, where the difference between the Reese's Pieces and the Skittles was much smaller than that of the M&M's. But the idea is the flap lowers down, and at different levels. And really, this could be bottomless here. It could go all the way vertical, so any leftover candy just drops. But at the different levels, the Reese's Pieces come out here, and the Skittles come out here, and the M&Ms go at the bottom, since they have the most friction and are least likely to slide. So that would give us that subdivision, and then it's just a matter of getting these various chutes at the right height. The Reese's Pieces could be as tall as this, and then the Skittles one has to fill the gap between Reese's Pieces and M&Ms, and then M&Ms is everything that comes out underneath. So just sort of establishing those sweet zones so that we can get the most of each candy. So what I'll be doing is a number of experiments to determine, given this material, which is sort of this placemat, or not placemat, picture backing. And by the way, this is just like a stock thing that came in a picture frame. Using this, what angles sort of create like the bell curve for that candy, so that if we have the angle represented along the x-axis and the amount of candy dropped along the y-axis, you might get a sort of bell curve of different candies dropping at different angles. And so it's a matter of getting those chutes positioned such that they the edges of the chutes are in the valleys between the various bell curves for when the candy slides down. If I can do that, then I'll have the highest possible accuracy, and if it's mostly accurate, that'll be good for me. So this is a moving flap. The limitations of it are numerous. One is that it's slow. It can only do one candy at a time, and this flap has to move slowly so that, like, if the bottom drops out, then just the jolt of having dropped down is going to cause the candy to come out no matter what it is. So the slower it goes, the more accurate it is. And the faster it goes, the less accurate it is. It's possible that it will be able to just like tick, 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 but we'll see. Also, the accuracy, I imagine, will be improved by the length of the flap. That way, like, slight jitters won't be too much of a problem. The other aspect of that is that it's a little more complex mechanically. So I am not an engineer, and so I don't know I don't know a lot about a lot of things, and sort of this back and forth motion adds a little bit of complexity. And I get that I can do that by having like a rotating gear with a lever arm and something there, so that this arm will sort of go through the thing here and sort of reciprocate up here. So I know that's how these can work, but that's just sort of a bit of complexity in design that it'll take a ton of trial and error to get it right. But once I get that set up and can sort of get the gear moving and you know, get it appropriately changing the angle on this, then I will be able to uh, control the flap and therefore hopefully get accurate results. Okay, so the second design option, and I'm using thinner paper now, but it's bleeding, so that's fun. Is the wheel. So the wheel um, is a bit faster. So my idea for this is that you have a wheel with so it's going to be like a tube, really, and the tube is going to have cards made up like this. So multiple flaps essentially, and they're going to be sticking out like this. I'm trying to do a 3D drawing, and it's of course pretty awful. So the cards all stick out like this, and it's a 5-card wheel. And so the idea with this is that we have, again, a hopper up here dropping Skittles down one at a time, but the big or candy down one at a time. But the big difference is that instead of having a flap that has to go down and up, you just have a single wheel that is going around and around and around. So this goes around and it lowers down, and same chute design that I did before. So you know, it's got the M&Ms, the Reese's Pieces, and the Skittles, so the flap, you know, it'll slide off the flap into the appropriate chute. The difference is that there's no back and forth motion. It just goes around and around and around, and so that means there's less concern with just doing one at a time. It'll drop the next one. You know, there could still be a candy sitting here and a candy sitting here when it's dropping the next candy down. So that would definitely speed things up. It, you know, basically sped up by the number of cards there. And also simplifies the machinery because it's just a rotating wheel. So both of those are really nice. The big problem is that this design here is a bit more complex. Instead of building a you know, single flap, I'm now going to have multiple flaps. I would need to build like a wheel that has an axle and has the different cards within it. So that would definitely add a challenge because I don't have any sort of fabrication experience. I do have circular things that I could try to build this out of, but it does run the risk of just being much more difficult. I'm going to see if I can maybe do this out of Legos. So one, it's fast. I should really have removed all of these extra sheets. Or I should have one sheet to bleed through on. This will be my sheet to bleed through on. So 2, it's mechanically simple. And 3, it is complex fabrication. So I'll have to think about that. The nice thing is that this chute design is pretty consistent. In both my designs, it'll be very similar, so I can get to work on building that. The hopper up top, I have some ideas on that as well. So hopefully I'll be able to come up with something that works well. Yeah, I think what I might do is start out, since the big question is going to be like whether this, like if I can build this, this will be the superior design. So I'm going to do my best to build this, and if I succeed, then I can go with it. If it fails, then I'll go with the moving flat. So I built this testing rig out of Legos and some clothespins in order to accurately measure the angle at which various candies slide off of this piece of cardboard. So it's got a little winch system here with a brake so that I can stop it precisely where I need to, and it goes really fast, so I'll be twisting that manually. But I'm going to use this to determine at what angle the various candies slide off in a way that is both testable and reproducible, hopefully. Let's fix that. Okay, so I've collected a whole bunch of data. I'm going to call it a night with that.